Today we're going to take notes on 7.6. We are finding the inverse of a square matrix. So we can only find the inverse if our matrix is a square, so that means it can only be a 2 by 2 or a 3 by 3 or a 4 by 4 or like a 10 by 10, but we'll limit it to these. So some of the problems we're going to have to prove that that the matrices are inverses. Towards the end, we are going to find what the inverse is. So the inverse matrix looks like this, where we have a diagonal of 1s and a diagonal of 0s. This is our identity matrix, and then we denote the inverse with the little -1 up top. So the inverse of A would have that little -1 up top. So to find if two things are inverses, we have to multiply A times B, and we're going to get our identity matrix, which is 1, 0, 0, 1. But we also have to multiply B times A. And we have to get the same thing, 1, 0, 0, 1. So if both of these things are true, then we proved that A and B are inverses. So this is how we prove two things are inverses. We just multiply them together both ways. So we have to multiply A times B and then B times A. So let's look at our first example. So again, it says here, multiply A times B and B times A to prove. So let's start with A times B. So I'm just going to rewrite them both here. That way they're right next to each other. We don't make any silly mistakes. So I'm multiplying A times B. How do I multiply two matrices together? So we move, in our first matrix, we move in rows. The second one, we move in columns. So we multiply the first row times the first column. So we have, our matrix is going to be -1 times 1, which would be -1, plus 2 times 1, which would be 2. 1 plus 2 is 1. Now we move on to what? We just did the first row, first column. First row times the second column. So we have -1 times -2 would be +2, plus 2 times -1, which would be -2. So 2 plus -2 is 0. So far, we're off to a good start. What's next? Second row times the first column. So we have -1 times 1, which would be -1, plus 1 times 1, so 1. -1 plus 1 is 0. And then lastly, we have the second row times the second column. So -1 times -2 would be +2. 1 times -2 would be 1 times -1 is -1. So 2 minus 1 is 1. So is this our identity matrix? Yes. So we multiplied A times B and we got what we wanted. Now we have to multiply B times A and get the same thing. So we always have to do both just to check. So we start with B. So we have 1, -2, 1, -1. And then A, -1, 2, -1, 1. And we multiply. So we start with our first row, first column. We have 1 times -1 is -1. -2 times -1 is +2. -1 plus 2 is 1. Where do we go next? first row, second column. So we have 1 times 2, which is 2. Negative 1 times 1 is negative 2. 2 minus 2 is 0. What's next? Second row, first column. 1 times negative 1 is negative 1. Negative 1 times negative 1 is positive 1. Negative 1 plus 1, 0. And then what's last? Second row, second column. 1 times 2 is 2, plus negative 1 times 1 is negative 1. 2 minus 1 is 1. Did we get what we wanted? Yes, so our A and B matrices, inverses of each other. Yes, so we proved that B is the inverse of A, so yes, it is an inverse. Alright, so next we're going to be finding what the inverse is. Okay, so the first thing we need to do is look at the matrix that it gives us. We have a major diagonal here. So if we had matrix that had the numbers A, B, C, and D, the diagonal A and D is our major diagonal, and then C and B is our minor diagonal. With our major diagonal, we switch the two numbers, so we switch their place. So if you notice in the purple box down here, D goes in the spot of A goes in the spot of D, so we just switch them. And then in our minor diagonal, we make them negative. So they stay in the same spot, they just both become negative. So it becomes a negative C and a negative B. And then we have to multiply them by the determinant, which is this. So this is our determinant. We'll get more into the determinant tomorrow. Tomorrow's notes are all about the determinant. But we just need to know that the determinant is 1 over A times B minus A times D minus B times C. So we have to multiply this times our matrix. So this is just a scalar out front. It's going to be some number that we have to multiply to our matrix with A and D flipped and C and B negated. So first thing we want to do is find our determinant. So our determinant is 1 over A times D minus B times C. So this is A, B, C, and D. So we have 1 over A times D. What's A times D? Three times 2, which is 6. And then what's B times C? 2. So 6 minus 2. So 1 over 4 is our determinant. That's going to be our scalar that we multiply by our matrix. And the matrix that we have to multiply it to, we have to switch our major arc. So switch these. And then negate our minor arc. So A goes in the spot of D. So down here we have 3. Up top in the left-hand corner we have 2. What would go in our upper right-hand corner? So with our minor arc, we just make them negative. We switch the sign. So if it's already negative, what would we put there? Our upper right-hand corner. Just 1. And then what would go in our lower left-hand corner? 2. And then we just multiply this by our determinant, which is 1/4. How do we multiply by a scalar? What do we have to do with that? Yeah, we just multiply each number by it. We distribute it to everything. So 1/4 times 2 would be what? One half. Awesome. It would be 2 over 4, which simplifies to 1/2. What's 1/4 times 1? 1/4. 1/4 times 2? 1/2. And 1/4 times 3? 3/4. So this is our inverse of matrix A, and we would call it the inverse by saying it is A to the power of -1. So that's just how we denote the inverse. If we said A is equal to this matrix, it would be wrong because this is not A. A is up here. This is the inverse of A. Any questions? All right, next one. We have to find the inverse of B. So first thing we want to find is that determinant, that scalar that we multiply out front. So that is going to be 1 over A times D minus B times C. This is A, B, C, and D. So this is 1 over, what's A times D? 6. And then what's B times C? 6. So this is 1 over 0. Can we get 0 in the denominator of a fraction? No. So this matrix does not have an inverse. Not possible. There is no inverse here. Anytime you get 0 in the denominator, it is not possible. Bless you. Can't have 0 in the denominator. All right, last example. So we have to find the inverse. First thing we're going to do is find our determinant. We have 1 over A times D minus B times C. What's A times D? -3. And then what's B times C? -4. So this is -3 minus -4. What's -3 minus -4? 1. Awesome. This becomes a big plus sign. -3 plus 4 is 1. So this is 1 over 1. 1 over 1 is 1. So we're just multiplying it by 1. Easy peasy. So what is the next thing we need to do? Awesome. We switch A and D. So we just switch their positions. So this becomes -3. This one's 1. What do we do next? Make C and B negative. We got to flip the signs. So what would our new B be? -4. And then what's our new C? 1. And then we're just multiplying this all times 1, which would give us the same thing. Yes. Yes. So our inverse matrix is -3, -4, 1, 1. How could I check to see if I did my math right? How could I prove that this is in fact the inverse matrix? Awesome. We would multiply matrix A times the inverse matrix A. And we also have to multiply the inverse matrix by matrix A. So this would be to prove. Which you could do it and see if it works if you wanted to. So to prove, we would just multiply our original matrix by the inverse and then the inverse by the original.